Hello everyone, and today's question is remove all adjacent duplicates, right? So you're given a string s here, and uh, you're allowed to remove duplicates in this string, but only if they're adjacent, right? So I'll be allowed to remove bb because these are the same letters that are adjacent here, right? And I can do this as many number of times as I want on this string, right? So uh, in the end, I have to return the final string that is left after I have done all the possible duplicate removals that can be done. Okay, so in this case, what will happen is for the string s that is given here, so we'll have a b a CA, right? Now, a brute force solution would just be to go through the entire string and search for any duplicates here, adjacent duplicates here, right? So this BB is an adjacent duplicate pair. So if I find something like this, I'll just remove it and I'll carry on ahead to the rest of the string. Now, once I'm done with that, I need to go back to the start of this string and do this again, right? So again, I'll move to the start of the string and search for two any two adjacent characters and check if they're equal or not. So here again, I find A are equal, right? So I'll have to remove these two, and then carry on to the rest of the string. Then again, I'll have to go to the start of the string and look for any two adjacent characters that are equal. But this string doesn't have any such characters. So if I reach such a point, then I can just return the string that I'm left with, right? But this algorithm will just be like a brute force algorithm, right? And the time complexity of this algorithm would be big O of n square if the length of the string s is n. And that's pretty slow. We don't want that. So uh, let's try to think of better algorithm, right? Uh, to do this, we can use stacks, right? So what the algorithm basically would be is that we just move through this string s once, right? And every time I encounter a character, I check the top of the stack, okay? And if the element of the at the top of the stack is equal to this current character, then I pop off the element at the top of the stack, and uh, that's all I do. But if they're not equal, then I append this character to the top of the stack. All right. Uh, yeah. So let's see a dry run, and that should explain why this actually works also. So the first letter is R, so we can just put R here, and the next letter is K, right? So K isn't equal to R. That means we can add K to the stack. The next letter is C, right? So C isn't equal to K, so we can add C to the stack. Now the next letter is C here, right? And this C is equal to this C, right? So I'll have to pop off this top element, and that's all. And now, uh, and now let's go to the next element, right? So this K here, uh, this K here is equal to the top element of the stack, right? That is also K. So I'll just have to remove this top element, right? And again, for this R here is equal to the top element of the stack again. So I'll have to remove this R2, right? And keep going forward. And now the new element that I have is W. So let's put W to the stack. Uh, Now the new element I have is A. So let's push A to the stack. The next element is A again. So this A is equal to the top element of the stack. So I should just remove that, right? The next element I have is B. So let's just put B into the stack. And the final element I have is W. And W isn't equal to B. So I can put W into the stack as well, right? And that's all. So now that we've made this stack, how do we figure out what the final string after removing all the duplicates actually is from this stack. How do we retrieve that? So the thing is that when we were passing through the string s, we were passing from the beginning to the end, right? So the bottom of the stack has the uh, has those characters that appeared earlier in the string, right? So that's why we'll have to read the stack from bottom to top, okay? And when we do this, the string we get is wbw. So we just return the string, right? And I hope you guys can see why this method actually works, because if we try to if I try to make the changes directly in the string, so I see that C and C are common, right, are adjacent duplicates, so I'll have to remove them. And now K and K have become adjacent duplicates, and that was kept track of by our stack when we were going through this algorithm, because it kept track of this of the previous element that hasn't been popped off in the stack, right? And that was K. So the next element, when we encountered a K, then we know that these are duplicates that have become adjacent now. So we can pop these off too. Similarly, it kept track of the element that came before K. So that was an R. And now the current element it has is also an R. And since this is equal to the top of the stack, it will just pop both of these off too. And it did the same thing for uh, yeah, for a while. So uh, mhm. So and in the end, whatever it's left with in the stack, that shouldn't have been popped off. And if we read it from bottom to top, then we'll get the string that is actually remaining in the end. So that's all for this algorithm. Let's try to code it now. So the code for this is actually pretty easy. All we have to do is just uh, make a stack first, and then we have to pass through the string, right? So for character in string, now the first thing I should check is if my stack is empty or not, right? So in case my stack is empty, I can't actually look at the top element of the stack because the stack is empty. So if the stack is empty, then I should just add whatever element I am add to the stack, right? And if it's not empty, then I should uh, check the top element of the stack. So that would be stack of -1. And I should check if that is equal to my current element or not, right? And if it is equal, then I should just pop that top element out from the stack, right? But if it isn't equal, then I have to add my current element to the stack. So this is what we discussed in the algorithm. So stack.append ch, and that's all, right? Now, after this loop runs, we'll be left with our final stack, and we need to read this final stack from bottom to top, right, to construct the string. And so in the case that I'm using an array to represent my stack, I'll have to read it from left to the right, right? And and when I'm reading this stack, like all I have to do is join all the elements of the stack into a string, right? Reading it from left to right. So I can do that easily by just using this join method for the stack. And the string that this returns, I can return that for this function, and that would be the correct answer. So let's try to run this code. Great, so it works on the sample cases. Let's submit it now. All right, great. Yeah, so this code works well, and yeah, so that's basically it for the coding part. Let's discuss the time complexity and space complexity of this code. So remember, our brute force approach was big O of n square, right? But this approach will just be big O of n in time, because we're just passing through the string s once, right, in this loop, and that's all we're doing. So that would be big O of n in time. But this approach would actually take big O of n in space, because I'm using a stack here, and in the worst case, the stack could be as big as my string itself. So yeah, So it'll be big O of n in time and big O of n in space. Yeah. So that's all for today's video. Thank you for watching, and I hope it helped, and I hope my explanation was clear. So if you guys have any doubts, just leave them in the comments. And yeah, thank you for watching. Bye bye.